So here I'm continuing. And for the next problem, simply multiply a couple of matrices. So I'm going to show you that on Symbol Lab. And I'm using problem 38 from the book. So let's look at that. And let's see, there it is. 38 says multiply matrices A and C with each other. So let me show you how to do that. Again, Google Symbol Lab matrix, click here. And now, in order to multiply, you could click on it says somewhere multiply here, for example. That's okay. I just did that. Didn't have to do that though. And then now you would have to say, I believe the first one was a 2x3 matrix. So I would do this and then times a 3x2 matrix. And then I would plug in the numbers here, which are from the book, for example, 4, -1, 1/2, and so on. Whoops, 1/2. And click and type everything in. But of course, again, I have it prepared. So here it is. And I hit the go button and it calculates it for me. And the way it's doing it is calculating, by the way, let's see, here's the solution, 1239/2, 1 and 0. Notice that turns into a 2x2 matrix. So the way it's doing it is 4 times 3, -1 times 1, 1/2 times 2, and add these. So it's the first row times the first column. And when you do that, you come up with 12, which then is the first row and column in the solution. Then you're going to do the first, trying to highlight just the first row. I can't. First row times second column. So 4 times 5, -1 times -1, 1/2 times -3. And when you do that, you come up with 39/2. And that would be the first row, second column. So there it is. And so on. And you can see easily that we do come up only with a 2x2 matrix because the first one only has 2 rows and the second one only has 2 columns. By the way, they have to match. Okay, it's really, again, straightforward how to do this one. All right, the next one then is the inverse of a matrix. And this is where it gets pretty cool, I think. So I'm going to go over here to the chapter in the book. So in the study sheet, I advised look at this example 6 here, where it says get the inverse of a matrix. So this is the original matrix here, get the inverse. By the way, it's down here, and that's quite a process. That's actually in that particular section on how to do that. So this one is the inverse of this matrix here. If you multiply the two with each other, you would come up with the identity matrix, the one that has ones across the diagonal and zeros everywhere else. So, and then it says you have 2 other matrices, 4x1 matrices, that then you're going to multiply with the inverse to get in the decoded message. So let's do the inverse first. So here's how to compute the inverse. Again, Symbol Labs matrix. There we go. Then it says on the side here, inverse. Click on that. And then this would be a 4x4 matrix. It has to be a square matrix. And then you would type in the coefficients. So when I look at that example in the book, it would be -1, 2, 0, -2, and so on. But of course, I do have it prepared. So here it is. There we go. And I hit the go button. Again, that's off the screen. And it computes the inverse of that. And of course, it does it actually with the identity matrix and then just going across. And it's quite a bit of work to do that. Eventually, you get the identity matrix on the left. And then this one here is the inverse. And you can double check that with the book. Well, let's do that. Notice the 15, -2, 4, 14. So let's check with the book. And we scroll down here. Here it is. 15, -2, 4, 14, and so on. 7, -1, 2, and 6. And so on. And let's see, where did I have that? Here, I believe. Yep, there it is. 7, -1, 2, and 6, and so on. Okay, so that's pretty slick with this inverse function. However, I have to say for the practical purpose of, I'm just going to erase this one here, of the next one, the decoding the message, let's do it just slightly different. We're going to use this little symbol here. And, okay, maybe not. hold on. I'm going to do this one here. First, here's my matrix, right? Now I'm going to use this little symbol, and I hope this is going to work. I think it does. And I'm going to put -1 here. And when you have a matrix, so -1, what it actually means is take the inverse of it. So I'm going to hit the go button. And when I do that, I come up with exactly the same thing for my inverse. And there it is again, right? 15, -2, 4, 14. The thing is, I noticed when I wanted to decode the message for the next problem, I couldn't do it for some reason with the inverse. Symbolab didn't like that. So I had to use that -1. So let me do that. In fact, I have it prepared, almost prepared, as so multiplying this one here with a, let's see, 4×2 matrix. And now I would plug in numbers that they give me here, so -30. So I actually take these two matrices, these two 4×1 matrices, put them together, -30, 26, and then my laptop keeps doing it, 109, and so on. And again, I actually have this prepared already, so let me just post that right here. There it is. So these are the two. These two numbers don't mean anything because they are encoded. So I'm using them with the inverse matrix to decode them. I'm going to hit the go button, and I will get a 4×2 matrix back when that is done. Here, in fact, it is. That's actually the solution. Notice the zeros here. That simply means there is no letter there. But then here, I'm going to look at the alphabet. 8 is the 8th letter, so that's an H. That's the 5th letter. That's an E. 12, that's an L, middle of the alphabet, right? 16, that's a P. So this one says help. And then it's not hard to see that this one probably says me, and that's exactly what they do in example 6. Is this still example 6? And there it says help me right there. And then when you go to the problem on the exam, let's see, which one is it? This one here, here's the matrix with the inverse. And again, this is actually the one that I give away here on question 10. Pretty much, I certainly didn't feel like making up wrong solutions. So, you know, there it is. There's 10 free points. But now you have to figure out you have to use this kind of inverse here and have to multiply with this one here. And you have to write it as a 4×2 matrix. So 53, 79, 18, -35, -176. Again, these numbers don't mean anything, but when you decode it, they do mean something, and it's going to be one of these 6 possibilities. Okay, and the last problem on the exam is the determinant. So as an example, I chose number 49 from the book. So let's see, almost there. There we go. So this is the one I chose. I'm plugging that into Symbolab. Again, Google Symbolab matrix, so you might already have it open. Click on it, and over here it says determinant, and when you click that, it's going to look like this. And then the example that I'm using is a 3×3 matrix. Yes, I'm going to click on here, and then I copy it from the book. So -7, 5, and so on. But of course, again, I got it prepared. So here it is. Okay, hit the go button off screen, and there it is. And then here's the solution. So the determinant is, oh, I did the DT twice. Okay, it looked a little funny. And in any case, the solution is -42. That's the determinant, but you have to describe how you get there. Well, the way to get there is to determine the cofactors. So it's -7 times the determinant of these 4 numbers. So 3 times 2 minus -2 times 0. So that's still a 6. And then -7 times 6 actually happens to be -42. So this one right here comes out to -42. And then you do the same thing for this one and its cofactors, and for this one and its cofactors, and so on. Turns out actually the other small determinants here come out to 0. That's why the first one already is the solution. This might not happen to the way you have it on the exam. So there you have to calculate a little bit more. Respectively, Symbolab is pretty much doing all the work here for you. All right, and that's the second part of the hints that I'm giving for exam 8.